student, this is the fourth part of relations. So almost concept completed. Today I am going to complete problem from subjective and objective. So students, listen. Yeah, a relation is given, any relation, whatever it may be. How to check that relation is reflexive or not? How to check that relation is symmetric or not? How to check the relation is transitive or not? Okay, if a relation is satisfied by these three, you can say that the relation is an equivalence relation. Okay. How to check a relation is reflexive or not? Reflexive. This is a relation, something a relation. We want to check the relation is reflexive or not. For example, a relation is given as a parallel. We want to check it is a reflexive or not. So what should do, Nana? So here and here you want to take same thing. For example, you want to take line L. Here also you need to take line L. L parallel to L, true or false, you need to check. L parallel to L, true only, no, every line is parallel to itself. That's why parallel is a reflexive relation. Okay. For example, you want to check greater than is reflexive or not. So reflexive, you know, here and here you take same thing. Greater than means this is the relation between numbers. Okay. So let here A, here also you need to take A. A greater than A, true or false? False statement. That's why greater than is not a reflex. Understood, students? So you want to check this relation is reflexive or not. What should do, Nana? You want to take one element, the same element. A related to A should be true. A related to A should be true. Then R is said to be reflexive. In this way, you can check for reflexivity. Next, symmetric. Second one, symmetric. Symmetric. When you can say that R is a symmetric relation. Observe, students, this relation from A to B gives the same relation from B to A. A or B should implies B or A, then the relation is said to be symmetric relation. So while interchanging these two also, the relation should hold. Then the relation is called symmetric relation. I will explain through example. For example, parallel given. A and B different, no? In reflexive both are same, different. Say L1 and L2. L1 parallel to L2 implies interchange these two and write, just write. L2 parallel to L1, just write and observe the statement true or false. L1 parallel L2 means implies L2 also parallel 1, true statement only, no? That's why parallelism is a reflexive relation, symmetric relation. You want to check for perpendicularity or symmetric or not. How to check, that is important. Here L1, here not L1, Anna. That is for only reflex, you know. You are checking for symmetric. So you need to take another one, say L2. Just you write, interchange and write. L1 perpendicular L2 implies L2 perpendicular L1. True only, no? L1 is perpendicular L2, automatically L2 also perpendicular L1 only. That's why perpendicularism is a symmetric relation. In this way, you can check the symmetry. One more example I will say. I want to check for subset is symmetric or not. Subset is symmetric or not. You take here A set, here B set. A is subset to B implies B subset to A. You write first, interchange and write. Now check whether the statement true or false. A is subset to B implies B subset to A. May or may not true, unless otherwise A equal to B. That's why that's why I can say that this relation is not symmetric relation. So in this way, we can check the symmetry. Now transitive, how to check the transit? Interesting, transit. A relation R is given. How to check the relation R is transitive? A related to B. R is a relation between A and B, and R is a relation of B to C. Gives the relation is from A to C. A related to C. The statement is true. Then you can say that the given relation is transitive. Once again, listen, students. A related to B and B related to C, and I will write A related to B and B related to C gives A related to C. R is a relation between A and B, and R is a relation between B and C. The same relation should be between A and C. Then you can say that the relation is transitive. I will explain through example. For example, you want to take parallel instead of R you want to take parallel. Checking for parallel. So instead of small a, I can write L1. So instead of this I can take L2, and B means L2 only, no, L2 is perpendicular to C means another thing, L3, implies L1 perpendicular to, parallel, no, L1 parallel to, parallel to L3. Statement true only, no, L1 parallel to L2 and L2 parallel to L3 implies L1 parallel to L3, correct only, no, 3 parallel lines are given, L1, L2, L3. L1 and L2 are parallel, L2 and L3 are parallel. What is the relation between L1 and L3? Parallel only. This statement is true. That's why parallelism is a transitive relation. Now checking very difficult. Perpendicularism, I want to take perpendicularism. I want to take perpendicularism, I want to check whether it is a transitive or not. Instead of R, I want to take perpendicular. Instead of A, I want to take a line L1. Instead of B, I want to take line L2. And instead of B, I want to take L2. Okay, perpendicular to L3 implies L1 perpendicular to L3. If this statement is true, then you can say it is transitive. L1 is perpendicular to L2 and L2 perpendicular L3 implies L1 perpendicular L3. If this statement is true, then perpendicularism is said to be transitive. But this statement is not true, because L1 perpendicular L2 and L2 perpendicular L3 means L1 and L3 are parallel, not perpendicular. I will show you. This is L1, this is L2 perpendicular. This is L2, this is L3 perpendicular. What is the relation between L1 and L3? Nana? Parallel. That's why this statement is false. Means that perpendicularism is not a transitive relation. In this way, you can check the relations. Very important, Nana. Okay, so first problem. Yeah, n equal to natural numbers 1, 2, 3 and so on and so on. A relation is given by x plus 2y equal to 6. Okay, x plus 2y equal to 6. Such ordered pairs you want to take. You want to take ordered pair x comma which satisfied by this, and these two should be natural numbers. Okay, do one thing, make y as subject. 2y equal to 6 minus x. Y equal to 6 minus x by 2. Okay, take x values, you get corresponding y values. X values can be taken from 1 to infinity. Okay, students listen. So, x is equal to 1, then y equal to 5 by 2, which is not a natural number, should be natural number. That's why I can't take 1 as the domain of the relation. Understood? So, in your relation or 1 comma something won't exist. If x is 1, y should be natural, here y is 5 by 2, not natural number. So, what is the meaning of this? Here you need to take only even numbers. X should be taken as only even number, Nana. If you take odd number, even minus odd by 2, not natural number. That's why what is the meaning of that? X must not should and even, that I will write. 6 minus x must even. That is x must even. No, instead of x I want to even numbers only. Okay, I will write directly, I want to write r equal to even numbers 2 comma something, 4 comma something, 6 comma something, 8 comma something, like that. Okay, one more thing, I can't take this x value greater than 6. You take x value greater than 6, 6 minus 6 not 0, 0 by 2 0, y equal to 0, 0 not a natural number, no? So I can take x as 8 also, 6 minus 8 minus 2, minus 2 by 2 what, no, minus 1. So what is the meaning of that? That also I will write. Even also 6 minus x should be greater than 0. That is x should be less than 6. What are the possible values now? Possible x are 2 comma 4 only, 2. 6 also I can't take, only 2. Okay, if x equal to 2, yeah, then y equal to here 2, 6 minus 2, 4, 2. If x equal to 4, then y equal to 6 minus 2, 1. Now I want to write r. What is actual r? Actual r is 2 comma 2 and 4 comma, only 2 ordered pairs. I think understood. Yeah. Okay, Nana. So x should be natural, y should be natural. First of all, y natural means 6 minus x is a multiple of 2. First thing. After that, y is a natural number means 6 minus x should not be negative. If x value greater than 6, 6 minus x becomes negative only, no? 6 minus 8, 6 minus 10. Okay, so that's why what I wrote, 6 minus x must even means x is even, one thing. After that also 6 minus x greater than 0 means x should be less than 6 means x is even and less than 6 only two possible values of x, that is 2 and 4. It's a natural numbers. Substitute x equal to 2, we got y equal to 2. Substitute x equal to 4, we got y equal to 1. Therefore, I can say that 2 comma 2 and 4 comma 1 are the ordered pairs in the given relation. Now, everything you can write. What is the domain, what is the range, what is the R inverse, everything you can write. Now, I want to write here. So, now you got R. Now, again I will write none here. What you got R equal to 2 comma 2 and 4 comma 1. In this relation, set of first components called domain. Dome, I can write dome of R equal to set bracket 2 comma 4. Range of R equal to set of second components. And R inverse, already explained how to find R inverse. Just you need to interchange x coordinates and y coordinates. 2 comma 2 interchange 2 comma 2 only. This is 1 comma 4. This is the R inverse. So, first problem completed. Okay, so now my second problem. A is given as 2 comma 3 comma 4 comma 5. R is given as something. R is reflexive. Explain. Okay. So, second problem. A is given as, observe all of you, 2 comma 3 comma 4 comma 5. If R is reflexive, then R must contain, so what ordered pair should contain? 2 comma 2 should be, 3 comma 3 should be, 4 comma 4 should be, and 5 comma 5 should be, and more extra. That is not big problem, but these 4 must and should. 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 4. That I wrote. No, if R is reflexive, then R must contain 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5. Contains are what? Contain, that is not big problem. So, this must and should, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, some extra. Yeah, but I will write, but what is given I will write, but R is given as, what I will write, where is that? 2 comma 3, 2 comma 4, 2 comma 2, 3 comma 3. Okay, next 3 comma 4, 3 comma 5, 4 comma 4, 5 comma 2. Now check, cross check. Yeah, 2 comma 2, okay, 3 comma 3, okay, 4 comma 4, okay. Where is 5 comma 5? 5 comma 5 must and should, no? So 5 comma 5 does not belongs to R. Therefore, R is not reflexive. Understood, student? So these must and should now 2 comma 2, 3 comma 3, 4 comma 4 and 5 comma 5 must and should, some extra ordered pair, that is not a big problem. That's why given relation is not reflexive. So I explained second problem also. Now third problem, which of the following relations in n natural numbers is symmetric. Okay. So one by one I want to write symmetric. First one, x greater than or equal to y. Just rule is given. No? You know how to check the rule is reflexive or not. Okay. What the relation means? Greater than or equal to relation. In the third problem, first mean what the relation means? Greater than or equal to. What is R nana here? Greater than or equal to. You want to check greater than or equal to reflexive or not? Reflexive. Now I want to check R is reflexive or not. How to check, nana? Here you want to take x, here also you want to take x. This should be true. Implies x related to y. I can say that this is meaning that x related to y. Meaning of that. So x related to y, x means what? X greater than or equal to x. X greater than or equal to x is true statement only. X greater than x not true statement, but x greater than or equal to x true statement. It is true. Therefore, R is reflexive. So, first one is reflexive. Oh, sorry, symmetric, no? Okay, actually you need to check for symmetric. I checked for yeah, reflexive. Okay, in this way you can check. Problem is symmetric. Okay, for checking for symmetric. Okay, what should symmetric? X related to y should give y related to x. Then R is said to be symmetric. First of all, I will take x related to y. What is the meaning of this? X greater than or equal to y. So, what is R related to x? What is the meaning of this? Y related to x. Means x greater than or equal to y implies y greater than or equal to x. Not true, no, this one. Unless otherwise x equal to y. Not true. That is why given relation is not symmetric relation. Okay. So, how to write shape, that is important. Okay. How to write, I will write again. Okay. X related to y should implies y related to x. Then only it is said to be symmetric. Yeah, what is the meaning of this? X greater than or equal to y should be gives y greater than or equal to x. But this is not true. Why I am saying this is not always true, that is the meaning. R is not symmetric. Okay, first main completed. I want to explain second one. Yeah, second one, just you need to create ordered pair, because x plus y equal to 6. X plus y equal to 6. This is different problem, first one. Second problem is different. Second problem, x plus y equal to 6 means you want to find the ordered pairs which satisfy x plus y equal to 6. Try to make y as subject first of all. 6 minus x. What is this? X should be natural number. 6 minus x also natural number. 6 minus x natural number means 6 minus x should be greater than 0. Means x should be less than 6. Okay. X comma y are natural numbers. That is 6 minus x should be greater than 0. That is x less than 6. Now, what are the possible x? Possible x. X are 1, 2, 3, 4, 5. Okay. Now, I want to find y values. If x equal 1, then y equal to 6 minus 1, 5. X equal to 2, 4. X equal to 3, 3. X equal to 4, 2. X equal to 5, what? 1. That's all. Therefore, the relation R equal to 1 comma 5, 2 comma 4, 3 comma 3, 4 comma 2, 5 comma 1. Now, you want to check it is a reflexive or not. 1 comma 5 means 5 comma 1 should be there. 2 comma 4 means 4 comma 2 should be there. 3 comma 3 means reverse 3 comma, that one only. So, all ordered pairs are there, required order. Therefore, R is symmetric. R is symmetric. So, this is one of the way. Another way also I will explain. This direct finding ordered pair. Without finding ordered pairs also you can solve the problem. I will show you. This is one of the way to solve this problem. Another one. So, x related to y in this problem means x plus y equal to 6 in this problem. X related to y means x plus y equal to 6. Now, I want to check this relation is symmetric or not. So, x related to y should give y related to x. Actually, x related to y means what, x plus y equal to 6. What is y related to x? What is, according to this definition, what is y related to x? Y plus x should be 6. If x plus y 6 means y plus x are 6 only, no? So, do one thing, interchange these two. Y plus x equal to 6, true statement, nothing happened, no? X plus y equal to 6 means y plus x are 6 only. So, what is the meaning of this? Y related to x. What happened here? X related to y gives y related to x. Therefore, R is symmetric. Students, important, two ways I explained this problem. First one general method, finding ordered pair. Second one theoretical method. So x related to y should give y related to x. X related to y means what, Nana? This. What you want, y related to x you want. Y related to x means according to this problem, what is that? Y plus x should be 6. So x plus y 6 is automatically y plus x 6 only, no? That means y related to x, x related to y gives y related to x, therefore R is symmetric. Students, first, second completed. Third one, x is a multiple of y. X is a multiple of y. I will write. Third one, R means x is a multiple of y. Or another words I can say that x related to y means x is a multiple of y or y is a factor of x. X is multiple of y. Now I want to check it is a symmetric or not. Means x related to y should use y related to x or not. Okay. Now I will take first of all x related to y. X related to y implies y. Sorry. Yeah, x is a multiple of y. So x is a multiple of y. Y need not be multiple of x unless other both are equal. Understood? That's why x related to y doesn't give y related to x. X related to y means what? The x is a multiple of y. Okay, what you want? Y related to x. Y related to x means y is a multiple of x. X is a multiple of y means y is not a multiple of x. For example, 10 is a multiple of 2 means you can't say that 2 is a multiple of 10. 2 is a factor of 10. If these two are same, this happens. Okay, that's why x related to x is a multiple of y does not imply. Does, sorry, I wrote something. Does not imply. Does not imply. Implies. Yeah. Y is a multiple of x. That is, x related to y doesn't imply y related to x. Therefore, R is not symmetric. Okay. Yeah, you people can complete this problem. Do one thing now, try to find ordered pairs. After that, easily you can find. Yeah, this problem also transitive. Just now explain. No? Okay, I will explain again. Two ways are there to these type of problems: making ordered pairs and without using ordered pairs. Okay. So fourth problem: given set n. So relation is from n to n. N cross n should find actually. Okay, given set is n, no? So from n cross n only you need to take ordered pair. From the ordered pairs you want to take the relation x greater than y is transitive or not. Okay, what I can write? Yeah, x related to y implies, first one, x related to y implies x is greater than or equal to y. Already we cross checked, no? X greater than or equal to y is not a symmetric, but it is transitive. I will show you. Okay. Transitive. Checking for transitive. How to check transitive? X related to y and y related to z should use x related to z. Okay. One by one. X related to y implies what, Nana? X greater than or equal to y. Next, y related to z means what? Yeah, y greater than or equal to z. So observe these two. X is equal to y or greater than y, and y is equal to z or greater than or equal to z. What is the relation between x and z? And automatically x greater than or z only, no? Implies x greater than or equal to z. Now I will write. Therefore, x related to y and so y related to z implies x greater than or equal to or x related to z. Therefore, R is transitive. Checking for transitive, x related to y and y related to z should use x related to z. Then only R is said to be transitive. Okay, student. Yeah, x related to y means this, Nana. y related to z means this one. So these two gives this, then only you can say that it is transitive. Observe now, x equal to y or greater than y greater than or equal to z. Automatically what happened? Relation between x and z. Automatically x greater than or equal to z only. That's why given relation is, yeah, what? Transitive. Yeah, here easy problem, you know, here this one on the same. Take ordered pairs, you can find out, or by using, without using ordered pairs concept also you can find. Better to take ordered pairs. Just now I explain now. X is 1, y is 5. X is 2, y is 4. X is 3, y is 3. X is 4, y is 2. X is 5, y is 1. So this is ordered pairs. Now you want to check these ordered pairs is transitive or not. So now 1 comma 5 is there. Checking for transitive, 5 comma 1 should be there. 5 comma 1. 1 comma 5, 5 comma 1. What should be there? 1 comma 1, 1 comma 1, 1 comma 1 not there. So it is not a transitive relation. Interesting problem. Interesting problem. So first of all, try to write the ordered pair satisfied by x plus y equal to 6. One of the method. After that, you need to check this relation is transitive or not. So I will write 1 comma 5 belongs to R, comma 5 comma 1 belongs to R. But 1 comma 1 does not belongs to R. Observe students, 1 related to 5 and 5 related to 1 should what gives 1 related to 1. Then only it is called transitive, no? Definition. What up here? 1 comma 5 belongs to R, 5 comma 1 belongs to R. 1 comma 1 should be belongs to R, 1 comma 1 not there. Therefore, R is not transitive. Students, very difficult. The relation concepts are very difficult. That too checking, very difficult. Please go through the concepts once again and you can solve the problems. I think I explained 4 problems. Yeah, okay students, our next problem, interesting problem. Prove or disprove. If R is a transitive, then R inverse is also transitive. Okay. Yeah. Prove or disprove, R is transitive, then R inverse also transitive. Let R is taken as x comma y comma z comma z comma x comma z, x comma z. See, clearly R is transitive, you know, x comma y comma z, then x comma z. Observe. So R is transitive. That is, R is transitive. Just I want to find R inverse. After that, I will verify whether R inverse is transitive or not. So R inverse. What is inverse means? Y comma x comma z comma y comma z comma x. Now I want to check R inverse is transitive or not. I already explained the procedure. Y comma x ordered pair is taken. Now you want to take another ordered pair started with x, not there. So no need to use y comma x. Next take z comma y. You take next z comma. You need to take another ordered pair started with y. There. That is y comma x. So it should use x comma z comma x. C is there. Z comma x is there. No problem. Next z comma x is taken. Now take ordered pair started with x. Not there. Means what the meaning of that? Given relation is satisfying transitive. Okay. So by the definition of transitive relation, R inverse is transitive. Okay, I proved if R is transitive, I proved that R inverse also transitive. Student, very important proving. For example, a relation is given R equal to 1 comma 2 and 7 comma 4 given. Check it is a symmetric or not. So some set A is given as 1 comma 2 comma 3 comma so on up to 10 8. R is reflexive, means 1 comma 1 should be 2, 1 comma only not there, no, R is not reflexive. Symmetric checking, 1 comma 2 ordered pair is there, means there should be 2 comma 1, not there. So it is not symmetry. Yet checking transitive very difficult. Observe all of you. 1 comma 2 is there. Another ordered pair should start with 2. Not there, no. For example, another ordered pair start with 2 and comma 7, and after that 1 comma 7 should be. If 1 comma 7 not there, then you can say that R is not transitive. But there is no ordered pair started with 2 only, no. Directly can say that it is a transitive relation. Very difficult, Nana. Please observe here. Very, very important. Some set A given. I found A cross A. From A cross A, I took some ordered pairs 1 comma 2 and 7 comma 4. Now I want to check this is a transitive or not. Transitive or not. What is the definition? 1 comma 2 are x related to y and y related to z implies x related to z. If this should be and this should be x related to y, and if have y related to z, then it gives x related to z. If this is not there, no need to check. Directly you can say that it is a transitive. Understood? What is the meaning of that? If these two are means x comma y ordered pair should be, and y comma z is there, then it should use x comma z. X comma y is in R, y comma z in R. If these two are there, means automatically x comma z should be. If then it is transitive, otherwise not transitive. But x comma y is there, y comma z only not there. No need to check. No need to check. How can you check? That's why in that case you can say that directly R is transitive. Students, important. X comma y belongs to R. Now I want to check transitive. Y comma something ordered by not there. No need to check for transitive. Directly you can say that it is transitive. Okay, now sixth problem. Interesting problem. I'll just skip 2 questions. Sixth problem. R be the relation in the set n of natural numbers. So R is taken is a subset of n cross n in inner meaning of the problem. Okay, so x minus y is a multiple of 3. X minus y is a multiple of 3. Means what is the meaning of that? X related to y implies x minus y is multiple of 3. I can write m of 3 just instead of multiple of 3. Okay, equal to m of 3 I will write. Okay, now you want to check this relation is equivalence or not. How to check, Nana? We need to check reflexive, symmetric and transitive. Okay, one by one. Reflexive. Difficult problem. Okay, what should check, Nana? X related to x true or not. That's all. X related x should be true, then you can say that is reflexive. X related x, by the definition, what is that? X minus x is a multiple of 3. That is 0 is a multiple of 3. Correct? Okay, students, what is the meaning of this, Nana? 0 is a multiple of the true, no? Which is true? Which is true? Don't think that 0 in n or not. That is not important. That is not correct meaning. X related to x should be true. Instead of x you take 2, Nana. 2 related to 2 means what is the meaning? 2 minus 2 is a multiple of 3. Correct only, no? Take 3 related to 3. 0 is a multiple of, correct only, no? What is the meaning of that? R is reflexive. R is reflexive. Now checking for, this is one part, symmetric. How to check symmetric? X related to y should use y related to x. Then you can say that it is symmetric, otherwise not symmetric. So x related to y gives x minus y is a multiple of 3. Take any number, now x minus y multiple of 3. For example, 9 minus 3 is a multiple of 3. Means what is the meaning of 3 minus 9? Minus 6 also multiple of 3 only, no? Integers, in integer sense you can say that multiple of 3 only. 9 minus 3 multiple of 3. Reverse of, so 3 minus also multiple of 3 only, no? That's why x related to y means x minus y is a multiple of 3. Implies y minus x is a multiple of 3. Correct only, no? Correct only, no? So what is, I can say y related to x. Means what happened? X related to y gives y related to x. Therefore R is symmetric. Now I want to check for transitivity. Hard one. Transitive. How to check transitive? X related to y and y related to z should give x related to z. I will write x related to y implies x minus y is a multiple of 3. Y related to z implies y minus z multiple of 3. What should get from these two? What should get? X related to z should get. Add these two or subtract these two, do anything. So you should get this relation. So x minus z multiple of 3. So observe student, something is a multiple of 3. Something is a multiple of 3. The addition also multiple of 3 only, no? Their subtraction also multiple of 3 only, no? Their product also multiple of 3 only, no? So what happened now? I will add these two. I will add, observe. I will add. What happened? X minus z is also another multiple of 3. Another multiple of 3. What is the meaning of this? Implying x related to z. Therefore, x related to y and y related to z implying x related to z. Therefore, R is transitive. So, R is reflexive, symmetric, transitive, then I can say that R is equivalence relation. From 1 comma 2 and 3, R is an equivalence relation. Okay.